Beyond the faint light of our sun, a very mysterious world is hidden. Beyond the last planet of our solar system and even farther than the mysterious world of the Oort cloud, in this infinite and mysterious dark space, there is a place that we have always dreamed of reaching. But perhaps reaching there is still a great challenge for human civilization. Our closest star system, a shining light that inspires hope in the night sky, makes us wonder if perhaps we are not alone in this universe. There is a hope about our home, wondering what if one day Earth becomes uninhabitable. This star system will be our new home. But along with it, there is also a troubling distance. What is it that makes reaching there seem almost impossible? And if we ever manage to combine our will and technology to cross this long distance to the Interstellar, what will we find there? A new world or another disappointment that will remind us how small we are in front of the universe? Get ready for an amazing journey to Alpha Centauri, because here we are going to solve many mysteries of Alpha Centauri. This journey will be amazing, will seem impossible, and will confront us with a truth that might force us to think about our universe and our own existence. The stars definitely call out to us, but at the same time, they also warn us that the path to them is surrounded by darkness. The universe is a system of mystery filled with complexity and astonishment. It contains three major celestial bodies, the Sun, the Earth, and the Moon. A star that is exactly like our Sun and is also officially called Mitra. The second star of this system is Alpha Centauri b. It is also called Ptolemy. And then there is the mysterious Alpha Centauri c, which is also known as Proxima Centauri, and it is a red dwarf, which orbits around these two at a distance of about 0.2 light years. A lone wandering star, which is right at the edge of its stellar family. Proxima Centauri has a secret, a planet named Proxima b. It was discovered in 2016. This rocky exoplanet is very close to its star, at just 0.049 astronomical units away, yet it is still in Proxima Centauri's habitable zone. So, could this be the second home for our human civilization? Is it possible, or are there certain conditions here that will keep this planet shrouded in mystery forever? Proxima is also our closest known exoplanet. It's only 4.24 light years away, which seems very close in cosmic terms. But what does this closeness really mean? A distance of 40 trillion kilometers. This is such a huge distance that even light, which is the fastest thing in the universe, even it takes 4.3 years to cover this distance. For humans like us, who are here in this universe for just a few moments, who are bound to their slow spaceships, this challenge becomes even greater for us. Reaching Proxima is not just a journey either. It's like making a bet with the impossible. So then, why do we dream of Proxima as well? Maybe because it's a mystery waiting to be solved. A piece of the puzzle that fits perfectly into the grand narrative of our existence. But before we set foot on this unknown land, we must face a harsh reality. A reality that asks us questions we might be afraid to face. The abyss between stars. Just think about it. The distance to Proxima Centauri. It's 260,000 times greater than the distance between Earth and the Sun. It's about 103 million times greater than the distance between the Earth and the Moon. Voyager 1, which is humanity's fastest interstellar spacecraft, would take 75,000 years to reach there. In 75,000 years, our civilization might have turned to dust. Or maybe by then, we would have long forgotten that we ever launched probes called Voyager. Parker's solar probe, the record-breaking spacecraft, travels at 700,000 kilometers h, Even it would take more than 6,500 years to complete this trip. These numbers are not just scary, they remind us that in terms of technology, we are still at a very early stage of development. Reaching Alpha Centauri is not a simple challenge. It will be a journey that will demand breaking through and going beyond the limits of physics, engineering, and human imagination. And yet, when we look into this infinite universe, a strange question arises. Are we meant to cross it? Or does the universe have some secrets that perhaps we shouldn't unlock? The Barrier of Light, a cosmic conspiracy. In 1905, Albert Einstein changed the way we understand our reality with his special theory of relativity. Among the many great mysteries of this theory was a harsh but clear truth. Any object that has mass will never be able to surpass the speed of light. This is not just a suggestion, it's a cosmic rule that cannot be broken, one that is forever embedded in the fabric of space-time. When an object accelerates, its energy turns into mass. The faster it moves, the heavier it becomes. Then there will come a time when it will need infinite energy to go any faster. Just think about it. If an astronaut reaches 99.9% of the speed of light, his 80 kilogram mass will increase to almost 2 tons. The closer you get to the cosmic speed limit, the harder it becomes to increase your speed. Crossing the speed of light is like trying to jump over a wall of infinite height. No force, no power can take you to the other side. Even if we reach the speed of light, the journey to Proxima Centauri will still take about 4.3 years. But this is just a best case scenario, a dream that is almost impossible because of vast energy requirements and the laws of physics. It seems impossible. Reaching such speeds is not just a technological challenge, it's a battle against the very nature and principles of reality. Winning it is also impossible for us. A glamour of hope, time dilation, and yet this universe is deafened by paradoxes. When a spaceship travels close to the speed of light, a strange phenomenon occurs. Time dilation. For a spacecraft traveling towards Proxima Centauri at relativistic speed, time flows slower for its crew. For an observer on Earth, the journey may seem to last several decades or even centuries. But for the travelers inside the spacecraft, it will feel like just a few years. But time dilation is not just a subjective compression. Just imagine a spacecraft that reaches 95% of the speed of light. For an observer on Earth, the distance to Proxima Centauri, which is 4.24 light years, it would take about 4.47 years to reach there. But for the crew, due to time dilation, this journey will only take about 1.39 years. The faster the spacecraft travels, the smaller this difference becomes. But if the spacecraft travels at 99.9% the speed of light, then for the crew, a 1-year journey will only feel like 2 weeks. And if the speed reaches 99.9999% the speed of light, then a journey that would take thousands of light years will be completed for the crew in just a few decades, or even sooner. This phenomenon raises a profound question. Can relativistic travel open the path to interstellar exploration? Maybe, but time dilation isn't a miracle. The energy required to reach such speeds is also unimaginable, and there are dangers like collisions with high energy particles, lethal radiation, and the destructive interaction with interstellar matter. All these challenges are still very great. At such speeds, even a thin layer of interstellar gas would turn into a deadly plasma. For both the spacecraft and its crew, empty space, which once seemed calm and completely empty, would become an invisible battleground, a battlefield where no spacecraft has survived yet. Time dilation does promise to take us to distant stars, but it also brings with it deep and mysterious barriers. Limitations of time dilation. As we saw earlier, taking a mass close to the speed of light would practically require infinite energy. So far, we haven't found any propulsion system that can make this possible. And even if somehow this energy problem is solved, even then, a spaceship that travels close to the speed of light will find space to be a very dangerous place. Space isn't empty. In fact, it's filled with countless wandering atoms. Sometimes these gather in complex forms as gas and dust clouds, galaxies, stars, and planets. And sometimes they wander alone as single atoms in this infinite universe. In 1 cubic centimeter of space, even the probability of collision between two hydrogen atoms is a different matter altogether. And during the journey of a spaceship, the certainty of an enormous flow of particles colliding with the spaceship is an entirely different matter. At low speeds, the particles are harmless, but with acceleration, they rain down like a dangerous shower. These can cause severe damage to the spacecraft in the form of projectiles and highly penetrating ionizing radiation, and the atmosphere inside the spaceship becomes extremely radioactive for the crew living inside. These are particles that travel extremely close to the speed of light. They acquire so much energy that they become a threat to any form of life. At such high speeds, even passing through a very thin nebular cloud can destroy an entire spaceship. Social and temporal disconnection. A lonely future? Even if we overcome all the technical challenges, there will still be an impossible problem left. Time dilation will have a devastating effect on the relationship between the spaceship and the home planet. For the crew aboard the relativistic ship, time will slow down significantly, but on Earth, the clock will keep ticking at its usual pace. The time that will feel like just 11 years for the crew will turn into millions or even billions of years for the people left on Earth. This harsh truth presents us with an existential dilemma. Astronauts who embark on such a journey will have to leave their world, family, friends, and even their culture behind forever. And when they return, Earth will have changed completely for them, or perhaps it may not even be habitable anymore. The society they once left behind will have been lost in the sands of time. Either it will have changed into some alien form, or it will have completely disappeared. The spaceship will no longer be a means of exploration, but will become their own little world, drifting alone through time and space. The effects of such temporal isolation can also be seen in the idea of the fictional United Federation of Planets like in Star Trek. The cultural and technological synchronization necessary for trade and cooperation will break down. Would a commercial enterprise have this motivation? To send cargo on a journey where there would never be any connection with the sender again? Such a journey would not be a transaction, but rather cargo that has neither an owner nor a destination. According to the laws of Einsteinian relativity, any spaceship embarking on such journeys would actually become a self-sustained world, completely different from its origin, drifting away from its purpose. So would this sacrifice be worth it? This sad conclusion aligns well with Enrico Fermi's famous paradox. If advanced civilizations exist, then why haven't we encountered them yet? Perhaps the answer isn't that they don't exist, but rather lies in the cruel barriers imposed by the laws of this universe. Time dilation presents a harsh reality before us, even if we manage to cross these barriers. For the crew of a relativistic spaceship, time on their planet will continue to move at its usual pace. The crew will return long after generations have passed and civilizations have risen and fallen. Their world will have completely changed for them, or perhaps it will have completely ended. So then, what would be the purpose of such a journey? A mission to Alpha Centauri is not just about crossing physical space. It will break those bonds of time and memories that connect us to humanity. They make us human. The Fermi paradox is a stark reminder. This conclusion leads us to a frightening and profound thought. which Enrico Fermi once asked, if advanced civilizations exist, then why haven't we encountered them yet? Maybe the answer lies hidden in the very limitations that we face. The distances between the stars are not just measurements of space, they are like strong fortresses of isolation. These are some barriers created by nature that hardly anyone would try to break. These barriers probably limit every civilization to its own celestial backyard, where the dreams of interstellar expansion burn like a weak lamp and eventually fade away. Despite Alpha Centauri being so close to us, it remains just a dream. It's only for those who are truly courageous and willing to sacrifice everything for their world. Does this show the non-existence of visitors? Is this a sign of the defeat of those civilizations? Or is it an even deeper warning that we are truly alone in this infinite darkness? On New Hope robotic explorers and light sails, we know that where humans can't succeed, maybe machines can. The future of interstellar exploration may be in the hands of robotic probes, miniaturized marvels capable of traveling at fractions of the speed of light. Concepts like von Neumann probes, which can self-replicate and colonize, could spread the essence of humanity to the stars. Or maybe laser sails, which would be driven by a focused light beam. Lightweight probes can be accelerated to up to 20% of the speed of light. And with this, Alpha Centauri can be reached in just 21 years. These solutions are not part of science fiction, rather they are very close to our reality. This journey still won't be easy and the obstacles are many, but humanity has never backed down from doing the impossible. Will these machines one day send us secrets that we never even imagined? Conclusion: the eternal mystery, Alpha Centauri, has always been a mystery that lies at the edge of human reach. It inspires us to explore the world. But at the same time, it reminds us of our limits. Whether it's in a century, a millennium, or maybe we never reach here at all. The dream of Alpha Centauri will always inspire humanity to look up at the sky, ask questions, and move forward. In the end, the journey to the stars is not just about exploration. It's about facing an infinite and unknown universe and finding meaning in that very quest. Are we meant to remain unknown here, or maybe one day we will become one with these stars? Whatever happens, this mystery will remain. Proxima, discovered a few years ago, is the most mysterious and amazing exoplanet found by humans to date. This planet is present in the closest star system to our Sun. Like Mars and Earth, this is a rocky planet. That means there is a solid rocky surface here. Unlike other exoplanets which are nothing but gases like Jupiter, this one has a solid surface. Proxima Centauri is a red dwarf star. That means it's a star that is living out the last few million years of its life. It has already lived through most of its lifespan, which is why the fuel inside it has been exhausted. After the hydrogen in any star runs out, the rate of fusion reactions happening there slows down, and it slowly starts to cool down. Because of this, the range of heat and light coming from it becomes much smaller. And because of this special condition, Proxima, even being so close to its sun, can still give birth to life within itself. Or you could say that it has already given birth, it's just that we humans haven't seen it yet. Well, in today's documentary, we will take you to the Proxima B planet, where you will be able to experience its environment firsthand. There, you will witness the sights of morning, evening, day, and night, and you will be able to understand the emerging system of life there. And dear friends, this Diwali we have brought a lot of amazing Diwali gifts for our viewers, so make sure to watch this video till the very end. So, are you ready to be a part of this amazing journey? If yes, then make sure to fasten your seatbelts, because our journey will pass through delays, dangers, and troubles. Well, for now, we are at our home, that is on Earth. From here, first we have to head towards outer space, which is at a height of 100 kilometers from the surface of the Earth. This boundary is known as the Kármán line. This is the region where the Earth's atmosphere ends. And after this, the harsh and tough weather of space begins. It took us just about 3.5 minutes to reach here from Earth. After this, we move on to our next destination. The International Space Station orbits approximately 400 kilometers above Earth's surface. Typically, it takes us about 2 days to reach here. But with our supersonic rocket, we reached here in just 29 hours. Next stop, the moon. Travel time will be 2.5 days. Now you can take out your blankets because we are literally traveling in outer space, where extreme temperatures can freeze you and at the same time burn you. But thanks to science, our spacecraft is equipped with all kinds of thermal protection, which is why neither the sun's radiation nor the extreme cold of outer space will affect us much. Oh, before we knew it, these 2.5 days just flew by. We didn't even realize it. Now, we will leave Earth's orbit and do a flyby near the moon. So get ready for a magnificent view. Wasn't that fun? Anyways, the journey ahead will be very comfortable and peaceful for you, because now we will only open our eyes when we pass near Mars. That means a wait of 8 whole months, by the way. That's even longer than a bear's hibernation. By the way, this is an imaginary situation where all the planets and the solar system have come into a straight line alignment. Because of this, we are moving forward on our journey while seeing all of them together. And along with that, we are also imagining here that our shortest trajectory to Proxima Centauri also follows a similar straight line pattern. So don't take these things too seriously, just enjoy this simulation and leave the rest to us friends. First Mars, then flying by Jupiter, Saturn and Uranus. Now we have reached the last planet of the solar system, Neptune. It took us a total of 12 years to reach here. Well, this speed is based on the reference of already existing rockets. But if we had used some experimental rockets that are currently in the research stage, this time could have been reduced to even 8 years. Under the same conditions, the rest of the journey ahead is going to take much more time. So now, please sit back and relax in your seats, because now our journey is going to be quite peaceful. Although we will encounter several asteroids along the way, we will handle and maneuver our spaceship accordingly. As for the feasibility of reaching Proxima Centauri, for now, this thing is next to impossible. If we set out on a journey to Proxima Centauri using current technology, it would take us 73,000 years, which is almost impossible. But if we break the limits of objectivity and let our imagination soar, then this time could be reduced to just 4.5 years. Yes, we are talking about speed, the speed of light. Suppose we somehow manage to build a spacecraft that can travel at the speed of light, disregarding special relativity and other factors. So at most, we would reach Proxima Centauri in 5 years, and after that, we could explore it. So let's accelerate and reach Proxima as well, at this speed of light. So guys, here we are now. In this fascinating image of the Proxima Centauri star system, you can see 3 stars orbiting together. But what do these two have to do with our destination? So this is the red dwarf star Proxima Centauri, around which this planet Proxima is also revolving. Come, let's sit. We enter its orbit and prepare for a smooth landing on it. Well, it's the beginning of the landing sequence. On the count of 5, we will be on the surface of this planet. So fingers crossed and eyes closed, because we are good to go. Friends, we have landed on the surface of this planet. As we take our first step here, who will be the first person to set foot on the surface of Proxima B? Well, our comment box will decide that. Go there quickly and raise the flag of your name. Let's go. With this, we make our trip a success as well. When you look at the view from the sky, it looks something like this. Here, more than anywhere else. The host star of this planet, Proxima Centauri, will be the brightest, while the other two major stars of this star system also have a bright appearance. Due to their odd elliptical trajectory, their view will seem very dim and flickering. Now, since this planet is quite similar to our Earth in terms of size and weight, that's why we will see a geography here that is quite similar to ours. The composition of this planet is mostly like that of Earth. Geomorphological surveys reveal that this planet has mountains, volcanoes, passes, and trenches similar to those on Earth. However, there are also some things here that don't match our planet at all, like the way this planet orbits its star. One side of it always experiences day, while the other side is in constant night. Its motion is such that one face of this planet is always facing its host star. Because of this, energy is always reaching that area. On the other hand, the dark side always remains in darkness and cold. In such a situation, this raises a lot of concerns about the possibilities of life, present on Proxima b as well. Because of this special condition, there is an extreme temperature difference, which makes it a bit difficult for life to grow stably here. But even here, there is still a way for a seed. In fact, the area of the seed is the point where it won't be too hot or too cold. In such a situation, life can easily originate there. Since this is a simulation and we are optimistic explorers according to us, this planet will also have a thick atmosphere with many gases wrapped around Proxima b like a blanket. There will also be dense clouds of water in the lower layers of this atmosphere, which would be raining liquid water, and whenever this water rains down on the surface of Proxima b, it would create a water cycle here again. In our speculation, we also imagine the presence of ponds, flowing rivers, and surging oceans on Proxima b. We also cannot rule out the possibility that the deadly solar flares coming from this planet's sun might have caused it a lot of harm. Because it is very close to its star, it is frequently bombarded by solar radiation and highly energetic solar flares. So they must be tearing through its atmosphere and entering inside, causing significant harm to any microscopic forms of life that might be developing here. These solar flares, which penetrate the atmosphere of Proxima b, can destroy the entire life cycle of this planet. But if somehow the planet's extremely dense atmosphere manages to protect itself, the state of life here would be something entirely different. There would be air to breathe in the atmosphere, and we would also see the existence of microscopic life forms here. Although we have shown you the sights of this planet through the sketches of our imagination, now it's your turn to embark on this endless journey through space. Mars has always been a source of fascination and wonder for humanity. From ancient myths to modern science and fiction, the Red Planet has always shaped our imaginations. A frontier of exploration and perhaps even a dream of creating a new world for us humans. Recent space technology advancements and the ambitious plans of space agencies like SpaceX and National Aeronautics and Space Administration have made the idea of colonizing Mars seem much more like a real possibility than just a beautiful dream. But will colonizing Mars be a smart move for humanity, or is it one of those dumb ideas that we shouldn't pursue? The prospect of becoming a multiplanetary species definitely excites us. But there are several reasons that raise the question: is Mars really the best choice for human colonization? The planet's hostile environment, lack of resources, and the immense cost and risk make the challenge of settling on Mars much greater. In this video, we will explore why colonizing Mars might not be as brilliant an idea as we think. We will discuss in detail the scientific, ethical, and practical challenges involved in creating a human colony on the Red Planet. And we will try to understand whether it would be better to focus our efforts on Earth itself or on Mars. So let's embark on this mysterious journey to Mars, where we will critically evaluate the dream of Mars colonization and find out if humanity's future is on the right path. Mars has a hostile environment, which is the primary reason. What makes the idea of colonizing Mars obviously a bad idea is the planet's incredibly hostile environment. In photos, Mars might look a bit like Earth. But the reality is that the world of Mars is extremely dangerous. It presents big challenges for human survival. Mars is a cold planet where the average surface temperature stays around -60 degrees Celsius. At night, this temperature drops even further and goes down to around -125 degrees Celsius, especially near its polar areas. Maintaining a habitable environment for humans in such temperatures would be very difficult. In this cold world, we will need a lot of energy to keep our habitats warm and to protect our equipment from freezing. Apart from this, compared to Earth, Mars has a very thin atmosphere which is mostly made up of carbon dioxide. Traces of oxygen and nitrogen are present in very small amounts. The atmospheric pressure on Mars is less than 1% of Earth's, which will make the conditions here even more challenging. No human can roam freely on this planet without a spacesuit. Sealed habitats will be needed to create a breathable environment, in which the life support system will produce oxygen and maintain air pressure. This makes the colonization effort even more complex and costly. We know that water is the basis of our life on Earth. But there is a severe shortage of liquid water on Mars. Most of Mars' water is in the form of ice or has mixed with the soil there. Extracting this water will be a big challenge in itself, which will require advanced technology and a lot of energy. Without a reliable water source, sustaining a human colony would be almost impossible. Even if we are able to meet the energy needs of a Mars colony, the challenges of living on Mars are still not over. Mars has neither a global magnetic field nor a thick atmosphere, which would protect our people there from cosmic radiation and solar particles. This radiation will create a serious health issue for humans. The risk of cancer will increase among the colony residents, and it can damage their tissues, even cause neurological effects, and even make serious changes to their DNA. To protect settlers from radiation, habitats will have to be built underground or covered with thick layers of regolith. This makes building a colony on Mars even more difficult and expensive. So we will have to survive on Mars in such conditions. For humans, living on Mars will bring a new challenge every day. So far, we've only talked about the conditions on Mars. But even worse than that are the terrifying natural disasters that occur there. Mars is known for its massive dust storms which can cover the entire planet. These can last for weeks or even months. These storms can even block the sunlight that reaches Mars. Because of this, the effectiveness of solar panels decreases and power generation becomes difficult. The fine dust carried by these storms can get into our equipment and habitats, causing mechanical problems. And for humans, it can also create problems like difficulty in breathing. Considering these challenges, it's clear that Mars is still far from being an ideal environment for humans to live in. The planet's extreme conditions make living here quite difficult and dangerous. And to deal with these, we would need such advanced technology and resource investment which doesn't seem realistic in the near future. Apart from environmental challenges, the idea of colonizing Mars also brings immense cost and risk with it, which need to be considered carefully. Establishing a human presence on the red planet demands a massive investment in terms of resources, time, and money, and there is no guarantee of success. Sending humans to Mars and building a self-sustaining colony will be one of the most expensive endeavors in human history. Estimates for a crewed mission range from tens of billions to hundreds of billions of dollars. It will also depend on the scale and scope of the mission, but building a colony here will demand even more funding, technologies, and the development of infrastructure. This cost will mostly be covered by governments, private companies, or through collaboration between both. But here on our Earth, there are also many serious issues like climate change, poverty, and healthcare. Some people argue that these funds could be better used to solve these problems. Investing in Mars colonization will divert resources from places where they are needed more. This somewhere forces us to think whether this would be fair to us Earthlings or not. Building a colony on Mars will also demand the development of advanced technologies, which either do not exist or we are still in the very initial phase of them. Technical challenges such as life support, radiation protection, sustainable farming, and waste disposal are substantial. Without thinking about these, we can't take even a single step forward. It can take years or even decades to develop these technologies, and even then, there's no guarantee of success. Along with technological challenges, there are also logistical challenges. Transporting equipment, supplies, and people to Mars won't be possible without multiple launches and a robust supply chain, with each launch costing millions of dollars. If there is any failure or delay in the supply chain, it will become a major risk for the survival of the colony. This shows how living on Mars will make human life uncertain. Living on Mars is still a distant dream, but we will face many difficulties just getting to Mars, the journey to Mars, or living on this planet. It will put the astronauts' health at risk. The trip to Mars will take about 9 months. In this, the astronaut will be directly exposed to microgravity and cosmic radiation. Staying in microgravity for such a long time will cause muscle loss, bone loss, and other health issues. Whereas radiation exposure will increase the risk of cancer. Even after landing on Mars, astronauts will have to face radiation, extreme temperatures, loneliness, and the psychological challenges of staying in one place for a long time. Due to the lack of medical facilities and the difficulty of returning to Earth in an emergency, these risks become even more serious. There are also several ethical concerns associated with the idea of Mars colonization. One major concern among these is the impact of human settlements on Mars' environment. Mars is currently barren. While we haven't found any signs of life there yet, with humans going to Mars, other organisms like bacteria will also reach Mars. For one, we don't know how these could mutate in the Martian environment and what kind of threat they might pose to us. And besides that, they will also contaminate the Martian environment, which could create major problems in our future scientific research. Also, sending humans to such a planet where there is no guarantee of survival raises an ethical question as well. Some people argue that sending people into such a dangerous and uncertain environment would be irresponsible. At the same time, once humans reach Mars, they will also start exploiting its resources. Is it justified to make so many sacrifices? This is one of the biggest fundamental criticisms of Mars colonization, a lack of a clear and compelling purpose despite the appealing idea of becoming a multi-planetary species. But it's unclear what the practical benefit of Mars colonization would be. Compared to Earth, Mars doesn't have those resources and conditions that can support a large-scale human civilization for a long time. And there's no point in establishing a permanent presence in such a place. Some people say that the primary motive of Mars colonization is just symbolic. The desire to prove that human civilization can achieve something bigger and more ambitious. But without a clear and feasible goal, it's very difficult to justify the immense cost and risk of this endeavor. Considering these factors, it's important to think about whether our efforts and resources could be used better somewhere else. Instead of focusing on Mars colonization, we could invest in addressing Earth's challenges, exploring other settlements in space, or looking into more feasible options, alternative options for space exploration. Despite so many drawbacks of Mars colonization, we still have several alternatives for space exploration and settlements that are more feasible in the near future. Space habitats offer immediate benefits and a promising alternative to Mars colonization, establishing human presence on our moon. The moon is quite close to our Earth, which makes reaching it easy and cost-effective. A trip to the moon takes only a few days, while reaching Mars takes us 6 to 9 months. Because it's so close, supplying and supporting a lunar colony becomes much easier, and many of the risks associated with long-duration space travel are also greatly reduced. The moon also offers us valuable resources like water ice, which can be used to make drinking water, oxygen, and rocket fuel. A lunar colony could serve as a stepping stone for exploring Mars and other planets in the future. Another alternative is to make space stations habitable either in Earth's orbit or in other places in the solar system such as Lagrange points. These space stations could be a good platform for scientific research, manufacturing and tourism, and could also serve as a base for Moon, Mars and space exploration. If you look at it, space stations have many more advantages over planetary colonies. They can be located in environments where temperatures are stable and constant sunlight is available, which is essential for solar power generation and energy needs. They can also be easily resupplied and maintained, which reduces many of the risks associated with long-duration space missions. Instead of colonizing planets, we can also focus on mining asteroids to extract valuable resources. Many asteroids are rich in metals and minerals such as iron, nickel, platinum, and gold. These can be used for manufacturing and construction. Asteroid mining can provide a sustainable source of raw materials for space exploration, and reliance on Earth-based resources can also be reduced. This can also help prevent deforestation and other forms of exploitation on Earth. Asteroid mining can help develop technologies and infrastructure necessary for future space colonization, such as in-situ resource utilization and advanced propulsion systems. Finally, some people believe that our efforts and resources could be used to address Earth's challenges instead of the Mars colonization project. So, this can also make Earth better. From climate change, environment, and poverty to inequality, there are many issues that need attention. By focusing on Earth, we can build a better society, which will be beneficial for all of humanity. Investing in renewable energy conservation and social programs can be more impactful than colonizing Mars. For the well-being of our planet and its inhabitants, the idea of colonizing Mars has captured the imagination of many people. But it is important that we take a step back and first critically evaluate whether this is the right path for human civilization. Obstacles like Mars's extreme temperatures, thin atmosphere, lack of liquid water, and radiation exposure make it very difficult and challenging to establish a sustainable colony there. There are also ethical concerns about how human settlements on Mars could impact its environment and potentially exploit its resources. Instead of focusing on Mars, we should focus on Earth itself. Besides, there are many ways to advance our understanding of space and the universe that are possible without the immense cost and risk of Mars colonization. It depends on us what we choose for the future of our humanity and our planet. What is your opinion on this? Do let us know in the comment section. How did you like this video? If you like this video, be sure to like it and share it with your friends.